3 receivers, 6 gigs, 1 source stream. Nothing is broken. A single camera feed, 3 receivers. How many times does that video actually cross the network? If you said once, you are wrong. It isn't once. It is 3 full copies from the source. In this video, we will discuss what multicast is solving for. No IGMP, no PIM, no multicast addressing. We stay inside plain unicast on purpose, and let's watch it break. A unicast packet has one destination address. That's the whole model. There is no field that says, also send this to 11 other addresses, please. A single packet, a single destination. This works maybe for a login session, but it breaks the moment an application needs to say, send this very same data to many recipients. Let's take a real number, a real example. One uncompressed 1080p stream at 60 frames per second, that is roughly 2 gigs and change. 3 destinations need that, for example. A multi-viewer, an SSD recorder, and a decoder. In the unicast world, from one source, that's not 2 gigs and change on the wire. That's 6 plus in a unicast reality. It's the same feed, but 3 separate streams, 3 separate and 3 different unicast addresses. At a 4th destination, a remote venue, and you're adding 2 more gigs on a link you may not fully control, an ISP or so. The cost of this appears in 4 different places. Number 1, the source NIC, transmitting content rate times receiver count, not just content rate. And the CPU, reading the same frame out of memory once per receiver before it even reaches the wire. Number 3, the first link out of the source. Every copy crosses it because nothing has divergence yet. And in a sizable network, every router downstream running an independent lookup for what looks to a human eye like the same traffic. To the router, however, these are unrelated flows. Every one-to-many system then has to answer the same question. Who is responsible for creating the extra copies? The bandwidth at the replication point isn't determined by the stream. It's determined by the stream multiplied by the audience that receive it. Fine if we have 10 receivers, but what if we have 10,000? If we apply the same math, that is no longer fine. This is why adding a bigger link isn't a fix for this. We are not solving a fixed cost. We are solving a cost that doubles every time the audience or receivers do. Design engineers often move replication somewhere else to solve this. Reflectors do this. CDN edge nodes do this. Both could reduce pressure in one place by creating it somewhere else. The replication, however, didn't disappear. It moved somewhere else. That's the point. The obvious next idea is let's broadcast that stream. One stream, everyone on the segment gets it. No replication at the source. This fails the other way. Every host and receiver on said segment will eventually pay the cost, whether they want it or not. It can't cross a router, push this hard enough, and it degrades every device on the segment at once. A broadcast storm of sorts. Let's stop here and think for a second. So, unicast undershares, broadcast overshares, and still can't leave the segment, as I'm sure you know. Neither is the answer then. Back to our original 1080p example. One source, 3 receivers. One shared uplink into a router. Source builds the content once. That's the last moment only one copy exists. Then it has to build 3 packets. The same payload, 3 destinations. All 3 will have to cross a shared uplink. That is the expensive part. There's no divergence yet. The router will have to perform 3 independent forwarding decisions. Then divergence will happen. Each packet will leave towards its own receiver. Only now does each remaining link carry exactly what it needs. The gap between the source sending and the paths splitting apart, that's where the cost lives. Every frame repeats this. This is what we need to solve for. From what we talked about so far, any scalable distribution system has to satisfy 4 conditions then. Number 1, send the data once regardless of receiver count. Number 2, deliver only to receivers who ask for it. Number 3, replicate inside the network, only where paths genuinely diverge. And number 4, work across subnet boundaries. Real receivers are never all on one segment. This is the reality of networks. In broadcast networks and AV over IP networks, a studio feeding multi-viewer or an SSD recorder and a transmission chain would be already at 65% capacity and close to saturating a 10 gig source interface in unicast before a remote venue is even added. Remote production would make this even worse. That shared uplink is likely a WAN transport, metered, outside local control, and costly. The first signal isn't usually packet loss, it's usually utilization. One link begins climbing with receiver count, while every downstream link remains stable. That's how this looks like. You usually should start with telemetry, finding the one link whose utilization grows with receiver count instead of content rate. In this video, we learned that unicast might be correct for one sender, one receiver, but it has no concept of many, unfortunately. Unicast solves a distribution problem by repeating a conversation, by repeating feeds. That's why the cost grows with the audience and receivers. That's it. Thanks for watching.